Hello students, here I am with lecture number 1 on curve tracing. Here we will learn basic rules to trace a curve. Actually, we are having three types of curves. First is Cartesian curves, second polar curves, and third is parametric curve. Other than these three categories, we are having fourth category which is Rose's curve. But it is a part of polar curve, but here we will take it separately. So let's start. First part of curve tracing, that is about Cartesian curve. So let's start with some basic definition. So first, point on the curve. So if any point AB satisfy your curve equation, that means if we put x is equal to A and y equal to B, then LHS will be equal to RHS. Then that point A comma B is on the curve. That point can be of four types. First one, it can be a single point. If your curve is passing through that point exactly once, then that point is called as a single point. But if your curve is passing through any point multiple of times, then it is called multiple point. Now under this multiple point, we are having double point. So if your point through a point, your curve is passing exactly two times, then it is called double point. Now the last one is a isolated point. So if any point satisfy the curve equation, but if we are not getting any tangent on that equation. So here just I want to tell you what is tangent. So if any curve, you can draw any curve. So at any point you are able to draw one tangent, right? So if your point satisfy the curve equation, but you are not getting any tangent at that point, then that point is a part of the curve, but curve will not pass through that point. It means it is a isolated point. Here we will discuss the double point. So before starting the double point, I want to mention here that if you are getting any point, then first you need to find out tangent at that point. With tangent only we can find out the nature of that point. Here at the double point we will get two tangent. Then only your curve will pass through that point exactly two times. Double point are of two types, one is node and second is cusp. If you are getting at a double point two tangent, but that two tangents are distinct and real, that means at the same point you are getting two distinct tangent. So as you can see in the figure, P is denoted as node. That means your one branch of the curve is touching one tangent and the other branch of the curve is touching another tangent. At the node point, your two distinct branches of the curve are touching two distinct tangents. Then it is called a node. So here you can see that at P point, your two branches are widely open. Now the second point is cusp. If you are getting two same real tangent at the double point, that means your one branch of the curve is touching one side of the same tangent and second branch of the curve is touching same tangent but from the other side. That means here two branches are touching same tangent at same point. That means here two branches are also touching to each other. That means it is a type of cusp. As I already mentioned, we are having four types of curves. One is Cartesian curves, parametric curves, polar curves, and rose curves. Cartesian curve, that means a relation between x and y. If you can express your equation as a y is equal to function of x or x as a function of y. Basic idea of curve tracing. So to trace a curve, we should understand 5 rules. These 5 rules are: first rule is symmetry of the curve. So we need to check the symmetry of the curve. Second, whether your curve is passing through origin or not. And if your curve is passing through origin, then we need to find out tangent at origin. Rule 3, we have to find out the intersection point with the coordinate axis. And then we need to find out tangent of curve at these points. Rule number 4, asymptotes. And the rule number 5, region of absence. That means we need to find out the values of x or y where the curve does not exist. So let's start with rule number 1, that is symmetry. Symmetry plays a very important role to trace a curve. If you want to draw your curve, then you need to draw it in all 4 quadrants. But if you know that your curve is symmetry about x-axis, so we will only draw our curve above to x-axis, and because of symmetry, the mirror image will appear below to the x-axis. So let's start with symmetry rule. So the first type of symmetry is about x-axis. To check it, we need to identify the powers of y. If all powers of y are even, then curve is symmetric about x-axis. In that case, f of xy is always equal to f of x minus y. That means if we replace y with minus y, then the equation will unchanged. For example, parabolic equation y square is equal to 4ax. Here y appears only one time with the power 2, and that power is even. That's why the curve is symmetric about x-axis. Second, symmetry about y-axis. Similarly, if all the powers of x are even, that means if we replace x with minus x and equation is unchanged, then the curve is symmetric about y-axis. For example, parabolic equation x square is equal to 4ay. Here x power is 2, which is even, then the curve is symmetric about y-axis. Now the third, if all the powers of x and y both are even, then the curve is symmetric about the both axes. For example, the circle equation x square plus y square equal to a square. So here x and y both are having even powers. That's why this circle is symmetric about x and y both the axes. If you replace x with minus x and y with minus y, an equation of curve is unchanged, then the curve is symmetric about opposite quadrant. As you know, in the first quadrant, x and y both are positive, while in the third quadrant, x and y both are negative. And second quadrant, x is negative, y positive, while in the fourth one, x is positive, y is negative. That means sign of xy are just opposite in the opposite quadrant. So if you change x with minus x and y with minus y and equation is unchanged, then the equation is symmetric about opposite quadrants. Next, fifth rule, that is about y is equal to x line. So to check the symmetric about y is equal to x line, we have to replace x with y and y with x. And if equation is unchanged, then the curve is symmetric about y is equal to x line. On a similar way, if you replace x with minus y and y with minus x and equation is unchanged, then the curve is symmetric about y is equal to minus x. So whenever you want to trace your curve, first you have to check all these 6 properties of the curve to find out the symmetry of the curve. Now come to rule 2, that is you have to identify whether your curve is passing through origin or not. If your curve is passing through origin, then you have to find out tangent at origin. If the origin, that is point 0, 0, satisfy your curve equation, then the curve is passing through origin. That is the simplest way to identify. But the second way, you have to identify whether your equation is containing absolute constant or not. If your equation is containing absolute constant, that means your curve is not passing through origin. What is the meaning of absolute constant? That means if your equation is containing a term which is purely constant, it is not multiplied or divided by any variable. Okay, so for example, I'm having the first example, that is x into in bracket y square plus a square is equal to a square x. So here if we put x equal to 0 and y equal to 0, then the LHS side is equal to RHS side, that is both are 0 0. Hence your equation or curve is passing through origin. Here in this equation you can see there is no absolute constant. Here we are having constant, that is a square, but in the LHS side also your a square x is there, and in the RHS side also here is a square into x. So that means constant is there but no absolute constant, hence your equation is passing through origin. Now second example, let it is x into y square plus a square is equal to a square. Here if we put x and y is equal to 0, so left hand side is 0 but the right hand side is a square, that means your curve is not satisfied by 0 0, hence curve is not passing through origin. Here in the right hand side, a square term is not multiplied by any variable, that means it is called as absolute constant. In the left hand side also we are having a square but it is multiplied by x, so we will not call it as absolute constant. So second way, this equation is also containing one absolute constant on the right hand side, that is a square, hence your equation is not passing through origin. Now if your equation is passing through origin, then we have to find out tangent at that origin point. To find out tangent at origin, we have to put the lowest degree term is equal to 0, or we can say the group of lowest degree term is equal to 0. Okay, so what does it mean? I'll just elaborate this point through the example. So let's first example, that is y squared into in bracket a minus x is equal to x squared into in bracket a plus x. So here if we put x equal to 0 and y equal to 0, then equation is satisfied. That means this equation is passing through origin. Okay. Now we have to find out tangent of this equation at origin. Then we have to separate out all the degrees term. So we can rewrite this equation as x cube plus xy square plus ax square minus ay square. That means we need to open bracket and we have to take all the terms on one side and we have to make the right hand side as 0. Okay, so here we will have this equation again. I just read it, that is x cube plus xy square plus ax square minus ay square. I have written this equation in the descending powers or degree terms. So here the first term is x cube, that means the degree of this term is 3. The second term is xy square, where x power is 1 and y power is 2. Then the degree of this term is altogether 3. Then the third term is ax square. A is constant, that means no degree, and x is power 2, then the degree of this term is 2. Now the fourth is ay square. So again y power is 2, then its degree is 2, and that is equal to 0. Okay, so here if we say 3 degree terms, so x cube and xy square both are 3 degree term. So x cube plus xy square are 3 degree terms because both terms are of 3 degree. Similarly, ax square minus ay square are 2 degree terms as both terms in this expression are of 2 degree. Okay, so we have to take the degree terms, group of same degree term with sign and with coefficients. Okay, so here we are having only two groups of different degree term. first group is of 3 degree and second group is of 2 degree. So here the lowest degree term, a group of lowest degree term is ax square minus ay square. So we will put directly this group of term is equal to 0. That is ax square minus ay square equal to 0. If we solve it, then we will get y is equal to plus minus x. So we are getting our equation which is satisfied by 0, 0. That means it is passing through origin, and at origin we are getting two tangent, that is y is equal to x and y is equal to minus x. So again we are getting two real distinct tangent at the same point, then it is a double point, and that double point is a type of node. So we have to correlate it with the previous concept, that is node and cusp. So here the 0, 0, that is origin, is lies on the curve and that is of node type, and here we are having two distinct tangent, y is equal to plus x or minus x. Now one note, if curve does not passing through origin, that means we need not to find out any tangent at that point. Second example for the same rule, I'm having second equation as y square is equal to x into in bracket a plus x. Now here again if we put x equal to 0 and y equal to 0, then this equation is satisfied by 0, 0. That means this curve is passing through origin. Now again by separating the degree term, we can rewrite the equation as x square minus y square plus ax equal to 0. So here the first term x square, which is of 2 degree, minus y square, that is also 2 degree. So x square minus y square is a group of 2 degree terms. Now the third term is ax, which is of 1 degree. So 1 degree term is only ax. So we will put the lowest degree term is equal to 0. That means we have to put ax is equal to 0. If we solve it, then we will get x equal to 0, that is y-axis. So we are getting y-axis is the tangent at the origin. Now come to rule 3, intersection with coordinate axis. So intersection with x-axis, as you know, x-axis equation is y equal to 0. So we will put y equal to 0 in our equation and get the values of x. If you are getting any value of x as real and other than 0, let it is h, then the point will be h comma 0. If you are getting x is also 0, then the point will be 0 comma 0, which we already discussed. So no need to discuss it again here. And if you are getting x value as a complex, that means imaginary value, then that means that point is not lie on the curve, because here we need to discuss only real point. So if you put y equal to 0 in your curve and get any real value of x other than 0, then only we will discuss that point here. And in that case, the point is h comma 0. Similarly, if you have to find out intersection with y-axis, and y-axis equation is x equal to 0. So you need to put x equal to 0 in your curve equation and get the value of y. If you will get the y value as a real other than 0, let it is k, then the point will be 0 comma k. With this, if your curve is symmetric about y is equal to x line, then you need to find out the intersection with y is equal to x line also. In that case, you have to put y is equal to x in your equation. Then the equation will be only in terms of x. By solving, you will get the value of x. If you will get any value of x which is real and other than 0, then only we need to include here. Let x, you are getting h, then the point will be h comma h. Note, anytime if you get any point, then you need to find out tangent at that point. As I already mentioned, if any curve is passing through any curve, then you can draw your curve by identifying the tangent at that point. Without tangent, it is impossible to draw the curve at that point. So if you will get any point either h comma 0, 0 comma a or h comma h, you have to find out tangent at all these points. So I'll just tell you how to find out tangent at these point in general. So let's find the tangent at arbitrary point h comma k. So find out dy by dx, that means just differentiate your equation and find out dy by dx from that. And put x equal to h and y equal to k. By putting x equal to h, y equal to k, if you are getting dy by dx equal to 0, that means your tangent at h comma k is parallel to x-axis, because then only your slope of the tangent will be 0. Now, if you are getting at p point dy by dx is equal to infinity, that means your tangent at p point is parallel to y-axis. Now the third point, if dy by dx at p point is positive, that means your tangent line form acute angle with the positive x-axis. Last point, if you are getting dy by dx at p point is negative, that means your tangent with positive x-axis makes obtuse angle. The curve attains its maximum or minimum values at the point where dy by dx equal to 0. Now, rule number 4, that is asymptotes. Asymptotes are the tangents to the curve at infinity. That means it is tangent which touches the curve at infinity. Here we will find out two types of asymptote. One is parallel to x-axis and second is parallel to y-axis. If we want to find out asymptotes which are parallel to x-axis, then we have to put the coefficient of highest degree of x is equal to 0. For example, let's one equation of curve, that is x square y is equal to a square into in bracket a plus y. So in this equation, if we want to find out the asymptote which are parallel to x-axis, then we have to identify the highest power of x. So we can easily see that the highest power of x is 2, that is x square, and its coefficient is y. So we have to put the coefficient of x square is equal to 0, that is y equal to 0. So y is equal to 0, that is x-axis is only the asymptote which are parallel to the x-axis. Similarly, if we have to find out asymptotes which are parallel to the y-axis, then we have to put the coefficient of highest degree of y is equal to 0. For example, the same equation x square y is equal to a square into in bracket a plus y. Here the y highest degree is 1, but it appears 2 times. So we have to combine first the coefficient of y. So if we take a square y term on the left hand side, so the coefficient of y is x square minus a square. So we have to put x square minus a square all together as 0. So we will get x is equal to plus minus a. So we will get x is equal to a and x is equal to minus a. These both lines, that is x is equal to a and x is equal to minus a, are asymptote which are parallel to y-axis. Note, maximum number of asymptotes can be n. That means n, which is the degree of curve equation. That means if your highest degree of the curve equation is n, then number of asymptotes Maybe n or fewer than n. It cannot be more than n. Here it can be lesser than n also, because sometimes we are getting complex asymptotes. Now in the same example, if in place of in bracket if we take a minus y, if we will take a minus y, then the coefficient of y is altogether x square plus a square. But if we put x square plus a square equal to 0, then we will get x is equal to plus minus ai. If we put x square plus a square is equal to 0, then we will get x is equal to plus minus ai. That means here we are getting two asymptotes, but both are imaginary. That means no real asymptote. Now come to the rule 5, that is region of absence of the curve. That means you have to find out the values of x or y for which curve does not exist. If your equation is solvable for y, that is y is equal to fx, then you have to find out the values of x for which y is imaginary. Means for these values of x, y does not exist, hence curve does not exist. On a similar way, if your curve equation is solvable for x, that is x is equal to f of y, then you have to find out the values for y for which x is imaginary. Means x values are not exist for these values of y. If your equation for this, you have to solve, your equation is either for x square or y square, and you have to check the values of opposite variable for which x square or y square are negative. Let's understand this concept through example. So take first example as y square into in bracket a square minus x square is equal to a square x. So to find the region of absence, first we have to find out whether this equation is solvable for x square or y square. If this equation will be solvable for x square, then you will be able to write down the x square value in terms of y, which is not possible here because we are getting two terms of x. One is containing x square term and second is x. So here we are not able to write down x square value only in terms of y. But on the other hand, we are able to write down this equation as a y square function of x, right? So we can separate out the y square term on the left hand side and remaining x term on the right hand side, right? So this equation is solvable now for y square. So we can rewrite this equation as y square is equal to a square x whole upon a square minus x square. Now we need to find out the values of x for which y square is positive, then the curve will exist for these values. And then next we have to find out the values of x for which y square is negative, hence curve will not exist for these values of x. But for x or y plane, x varies from minus infinity to plus infinity. So in all, we have to find out for which values of x y square is positive or y square is negative, which is very tedious task. So first we will divide the whole axis minus infinity to plus infinity into few parts. So how we can do this thing? So for that, just consider the right hand side of this equation second. So here right hand side is a square x upon a square minus x square. Now just put separately numerator and denominator equal to 0 and get the values of x. Like in this equation, if we put numerator, that is a square x is equal to 0. So we will get x equal to 0. Just mark this x equal to 0 on the x-axis. Now the second, we are getting a square minus x square denominator. Just put it also 0. So you will get x two values, that is minus a and plus a. So just put mark minus a and plus a also on the x-axis. So now you will get 5 points on the x-axis: minus infinity, minus a, 0, a, and last one is infinity. So total minus infinity to plus infinity axis is now divided into 4 parts. Minus infinity to minus a to 0, 0 to a, and a to infinity. Now we need to check in each part whether y square is positive or negative. If it is positive, then curve will exist. If it is negative, then curve will not exist in that particular part. Okay, so the first part is minus infinity to minus a. Write down it mathematically. Then it is minus infinity less than x less than minus a. That means x is negative, but it is strictly less than minus a. Okay, now if we put that value on the right hand side of y square, so what we will get? A square x. X is negative, that means numerator is negative. In the denominator we put x value, so x square will be positive, but numerically it is greater than a, so the denominator is also negative. Negative upon negative is positive, means for this part y square is positive, hence the curve exists. Now take the second part. Second part is minus a to 0. Minus a to 0, again x is negative, but it is strictly greater than minus a, means numerically less than a. So if we put these values of x here, so a square x will be negative, but a square minus x square will be positive. So if it is negative numerator and denominator is positive, then total y square is negative. If y square is negative, that means your curve does not exist in this part. Now take the third part, that is 0 to a. Write down mathematically. So it is 0 less than x less than a. X is positive, but it is strictly less than a. Now if x is positive, then a square x is positive. A square minus x square, because x is strictly less than a, then it is also positive. Positive upon positive, that means your y square is positive. If y square is positive, that means your curve exists. Okay, now take the last part, that is a to infinity. That means x is again positive, but numerically it is greater than a. Okay, now for this, your numerator x is positive, but the denominator, that is a square minus x square, will be negative. Now it is positive upon negative, that means your y square is negative. Y square is negative, that means your curve does not exist. Now take second example, that is a square x square is equal to y cube into, in bracket, 2a minus y. So here you can easily see that this equation is solvable for x square, but not for y square, because we are getting y cube and y terms also. Okay, so now this equation can be solved for x square and can be written as x square is equal to y cube whole into 2a minus y whole upon a square. Now again in xy plane, y can vary from minus infinity to plus infinity. So you have to break y-axis into parts so that you can easily identify for which type of values your curve exists, and for some values maybe your curve does not exist. Okay. So for that, on a similar way which we have done in the last example, we have to put the numerator and denominator of the right hand side is equal to 0. Okay, so here numerator is y cube into 2a minus y. Put it 0. So first value you will get y as 0. So just mark this 0 on the y axis. Now second factor is 2a minus y equal to 0. So here you will get second value of y as 2a. So mark 2a also on y axis. Okay, now put the denominator is equal to 0. Denominator is a square, which cannot be 0. So we will not get any value of y from the denominator. So now we will get only 2 points, that is y equal to 0 and y equal to 2a. We mark these 2 points on the y axis. So in total on the y axis we are getting 4 points, that is minus infinity, then 0, then 2a, then plus infinity. So this whole x is now divided into three parts. First part is minus infinity to 0. Second part is 0 to 2a. And the third part is 2a to infinity. So now here again we will check for these parts whether x square is positive or negative, and according to that your curve will exist or not exist respectively. Okay, so now take the first part, that is minus infinity to 0. Okay, so mathematically we can write it as minus infinity less than y less than 0. That means y is negative, simply y is negative, right? So now y cube in the numerator, y cube, y is negative, then y cube is also negative, right? Okay, now 2a minus y. Okay, 2a may say we have to subtract negative value. So minus of minus, it will be plus. So 2a minus y will be your positive value. Okay, y cube is negative, 2a minus y is positive, then altogether it is negative. Hence x square is negative. Hence your curve does not exist for these values of y. Okay. Now next region or part is 0 to 2a. Mathematically it is 0 less than y less than 2a. Okay. So that means y is positive and strictly less than 2a. Okay. So now y cube on the right hand side numerator, y is positive, then y cube is always positive, right? And 2a minus y, where y is strictly less than 2a, then it is also positive. So positive into positive, that means your x square is positive. X square is positive, hence your curve will exist for this particular part. Okay, now the last third part is 2a to infinity. Mathematically it is 2a less than y less than infinity. Okay, means again y is positive but it is greater than 2a. Okay, so on the right hand side y cube, y is positive, then y cube is also positive. Now 2a minus y is greater than 2a, that means it is your negative value. So positive into negative, it is always negative. That means your x square is negative, means for these values of y, curve does not exist. I hope you understood all the 5 rules which we have elaborated here in the lecture 1. Now we will use these 5 rules in further lecture 2 to trace Cartesian curves. Thank you.